Right. Now let's have a look at cells in parallel. Okay, and once again we'll do a paper experiment. So we'll have a look, we'll take the same old circuit, one cell, one lamp, ammeter, voltmeter. The cell is a 1,5 volt cell, and let's say that the lamp is a 1,5, what is it? Ohm cell. Lamp. Right. You've just had break, haven't you? Lesson ago? Quickly, run. Right, could anyone tell me, in this particular case, Nikita, what would my voltmeter be reading? 1,5 volts. What would my ammeter be reading? Well, if we had to say I equals V over R, what is V? 1.5. R also happens to be 1.5 equals 1 ampere. All happy there. So we haven't done anything, we've just started off. That's our baseline. So now we're going to double up the number of cells. So we're going to do the following. One cell, another cell. How have they been connected? Okay, you're also in parallel. I'm going to ask you in a moment why. What makes it parallel? Let's see. Could anyone tell me what makes that parallel? Dylan? No. Not when it comes to cells. What makes those cells parallel? We've connected positive to positive and then the negatives to negatives. So all the positives have been linked together and they go one way. All the negatives have been linked together and they lead off another way. All understand that? That makes it parallel. Right. And we'll put a voltmeter over that whole lot. Each of those cells, 1,5 volts, 1,5 volts. Right. And our lamp is still 1,5 ohms. Can anyone tell me what is the voltmeter reading going to be? 3. Who says 3? Who says 1.5? Who says you've got to say 1 over 1,5 plus 1 over 1,5? Who says you've got to do that? Doesn't that apply? That applies to resistors in parallel, not cells in parallel. So how do you work out the total voltage of those cells that are in parallel? It's easy. It's the same as if you only had one branch. What's the voltage of that one branch? 5. What's the voltage of the other branch? 1.5. So your total voltage, 1.5 volts. Who's got a question in this regard? The usual question is, what would happen if you had 2 branches? What's my voltage in that branch? And only one cell in the other branch. It gets a little bit more complicated. And fortunately, we don't have to worry about that at school level. Okay? You will always have the same number of cells in each branch. Or if we don't, I may put another cell in like that. Who can tell me what happens in the top branch? That cell and that cell cancel out. So how many effective cells do you have? 1 and 1. That I could get. Okay? Right. Let's have a look at what the voltmeter and the ammeter are going to say. The voltmeter, we said, will still say 1.5 volts. What is the ammeter going to read? Well, our formula for current never changes. I equals V over R. What is V? 1,5. What is R? Current is 1 amp. Right, let's give the lamp over here a rating. Dim, medium, bright. Dim. Yeah? Dim. How do we know it's still dim? Well, the current is 1 and the current is 1. So if the current's the same, the lamp will burn the same. Okay. Is it difficult? It's quite simple and straightforward. What's the third stage of this little paper experiment? 3 cells in. Connect all the positives together. Happy that I've done that? Connect all the negatives together. Happy that I've done that. Right. Link the positives around to the lamp. It's still a 1,5 ohm lamp. And take the negatives to the ammeter like that. 1,5 volts. 1,5 volts. 1,5 volts. How do I connect a voltmeter? How? Over the whole thing like that. What's it going to read? 1,5 volts. Right. All happy. So my voltage is still, let's write it in red, 1,5 volts. What's my current going to be? Same story, I equals V over R. V is still 1,5. Resistance is still 1,5. Still gives me 1 ampere of current. Right. Who can tell me what the conclusion is there? No, that's not really a conclusion. That's just a slogan that goes with it. As the number of cells in parallel. So let's change that to parallel. As the number of cells in parallel increases, so the voltage stays the same. And the current, what does the current do? Stays the same. Right, and the lamp burns with the same brightness. But for what? For longer. Okay, so how long did we say this thing would work for originally? 1 hour. If I've got 2 cells in parallel, how long would I get out of that? 2 hours. So that's the benefit, because I'm not getting the benefit of a brighter light. So some people may say, why bother with 2 cells? Well, I'll get the light burning for twice as long. And over here, it will burn for, so this will be still dim, but it will be 3 hours. So our conclusion is, cells in Cells in parallel, what are we going to get? They will burn for longer, but they won't burn stronger. Right. Right, are there any questions there? Okay. Now, where did we say we would use something like this? Have you all taken this down? Is anyone who's still taking it down? Quickly. Okay, can I take these circuit diagrams off? You finished with that pulling? Right. Could anyone think of a time or a situation where you would connect your cells in parallel? Come on, grade 11s, you fast asleep. When do you need a light that will burn for a long time? A torch. So a torch doesn't have to be bright. Or must a torch be bright? Yeah, but I want to know, when will you use cells in parallel? Give me a practical time, because that's what I'm going to ask you in your test. Give me a typical practical opportune time, for example, where you would connect cells in parallel. A child's nightlight. Okay. The purpose of the nightlight, is it to light up the room nice and bright? No. You just want a faint light. But what don't you want a nightlight to do? To go out after an hour. You want it to stay burning the whole night, but it's not there to light up the room. It's just to give a faint bit of light. Where would you connect cells in series. So car headlights, if you were running your car lights off cells, which you wouldn't be doing. Okay, but yeah, that would be, or a torch where you needed a bright torch, yes. Sorry, a street lamp if you had batteries running or cells running a street lamp. Right, can you think of an opportunity where you would want something to burn bright and for a long time? A spotlight. A lighthouse, yes. So something you don't want it to say, oops, hour's up, battery's flat, no more lighthouse. So it must be bright, but it must keep going the whole night or whenever there's fog. Sorry? Okay, in a laptop you need sufficient power to drive it and you want it to keep going for as long as possible. Okay. Anywhere else? Sorry? A what? A sniper's laser. No, no. A sniper, it's not bright. No, but it's okay. But it's not a bright light that lights up the whole room. Okay? And you're not going to be using it all the time for hours. You'll switch it on, off. Okay, so you wouldn't get a mark for that in the exam. Right. Okay, something like this. You wanted to light up the lab, but you want them to be on the whole duration of the day. So a typical light at home. As we said, most home lights or school lights don't run off batteries, but if they did, yes. Right, okay. What would you do in that case? You would connect them in series parallel. Okay, so if I said to you, let's right. If I said to you that connecting a cell on its own like that, right, gave you a dim light for 1 hour, right, how would you get a medium light for 1 hour? You'd add another cell in series. So that would give you medium for 1 hour. And if I wanted a dim light for 2 hours, I'd do it in parallel. That would give me dim for 2 hours. Right. If I wanted bright for 2 hours, what would I do? Bright for 2 hours. So let's stop first. Let's go 1, 2, 3. What does that give us? Bright for 1 hour. One hour. Now I want bright for 3 hours. So I'm going to have bright is 1, 2, 3, but that's only going to give me 1 hour. You agree? So you want to go another one like that. How many hours is that going to give me? 2 hours. So every branch doubles or adds on another length of time. You agree? So that's going to give me bright for 3 hours. All happy? What is this going to give me? Medium, 2 hours. Right, who'd like to come and do medium 3 hours for me? Ermela? Medium 3 hours. No, medium. I'm not going to put it there. I'd like you to put it here. Medium 3 hours. Eliminate it, don't take it off with your finger, use the eraser, otherwise those cells, I don't like them. Why is that last cell that you've drawn not a cell? No. Right, okay, thank you. I'm sort of happy with that. When you draw a cell, Ermela, that's not a cell. What's a cell? That line must be in the middle. So these lines need to be okay, right. So this is, how long is it, how bright is this going to be? Medium. And this is going to be 3 hours. I'd like you to fill in that portion of the table and that portion of the table for homework, please. Thank you. Everyone understanding? Good.